Consider the system of linear equations. Okay, and we're given a large system of equations here with solutions of the form w, x, y, z, where w, x, y, and z are real. Which of the following statements is false? The system is consistent. The system has infinitely many solutions. The sum of any two solutions is a solution. -5, 1, 1, 0 is a solution. And every solution is a scalar multiple of -5, 1, 1, 0. Okay, so my thoughts here first is to understand what exactly kind of thing we're looking for. I mean, so you know what, we can probably work through this pretty quickly. Okay, so the system being consistent means that there is in fact a solution, and we know that there is a solution to this because it's a homogeneous system. If you look at the equations, the right-hand side of every equality is 0. So we know we have one solution, which is 0, 0, 0, 0. Okay, so the system is consistent. An inconsistent one would be where you have a system of equations where they cannot all be satisfied at the same time. Part B, the system has infinitely many solutions. Well, this is probably true. I mean, just based on the context of the type of exam we're being asked this in, there's probably more than one solution to this. 0, 0, 0, 0 is probably not the only solution. Again, you would have to work through the details of the coefficients to see that, you know, this matrix is not invertible or something like that. I don't immediately see any of the equations that can be added together or multiplied by a scalar to give another one. But yeah, I'm sort of just, I'm pretty sure there's probably more than one solution, which means in fact there are infinitely many solutions. But we'll come back to part B, option B, in a second. So part C, the sum of any two solutions is a solution. This is also true, and this is because it's a homogeneous system. This is just the nature of linear systems, that if you have two solutions to a homogeneous system, then the sum of those solutions is also a solution. So C is true, so that's not going to be the correct answer here. Option D, we can just check this by direct substitution. And again, given the context of this exam and how the question's being asked, this is probably true. Why don't we start with that one and work through whether that is a solution. In fact, I'm not going to do this by writing it down. I'm just going to look at the equations and mentally make the substitution of -5, 1, 1, and 0. So it clearly works for the first and the second and the third and the fourth equation. Yeah. Just doing the mental math. Z is equal to 0, so you're essentially just adding multiples of the first three coefficients. So D is correct. C is correct. And because D is correct, we know now that B is also correct. If I have one non-trivial solution to a homogeneous system, then every multiple of that non-trivial solution will also be a solution. However, option E is the one that we can rule out. Option E is false, meaning that is in fact the correct answer. Now I haven't actually shown this, I've only worked it out by process of elimination here. But I've argued that options A, B, C, and D are all true. And so option E is the only one that can be false. I'm not going to verify it and show with a specific example, but what is going on here is that it is true that every scalar multiple of this point -5, 1, 1, 0. Every scalar multiple of that is a solution, but there may be other solutions which lie along a different four-dimensional direction vector. So yeah, this is the correct answer to this question, E. Don't really have too much more to say about this one, but if I do, I'll put it down in the description. Thanks for watching.